Service bus queues. Now, what are these service bus queues used for? See, in an application, many times we have got the concept of sender and consumer. Sender is responsible for generating the message and consumer is responsible for consuming the message. We call it as sender or we call it as producer, it is same. Likewise, we call it as receiver or we call it as consumer, it is same. So we have a sender wanting to send a message to the receiver, but what is also important is both sender and receiver, the two applications may not be running at the same time. When the sender is sending the message, at that point of time, the receiver may not be live. And at the same time, when the receiver is receiving the message, the sender may not be there. So we wanted asynchronous communication between the sender and the receiver. Thus, we want something in between which is going to persist the messages. And that is where we can make use of the queue. Now in service bus queue, we are going to post messages. And each message is going to have body, which is a binary data, I can say byte array, and a message is going to have properties, which is a collection of key value pairs. So as you can see here, a message has a body and a message has properties with key value pairs. So sender is going to create a message and put it in the queue. Receiver is going to receive the message from the queue. Now what is this load balancing? Now the biggest advantage of the queue here, the service bus queue, is load balancing. If the load in the queue increases, what we can do is increase the number of receivers so that the processing of the messages can be faster. And not necessary that all the consumers, that is the receiver, should have the same processing power. Some might be running on lower speed machine and some might be running on high speed machines. So each consumer might be a different type of application altogether, running on different processing power, and they are going to pull the messages from the queue. Very important point here. At any point of time, a message posted by a sender can be consumed by only one consumer. We cannot have more than one consumer consuming the same message. I repeat, a message posted by a sender, producer, can be consumed by only one consumer, though we might have multiple consumer applications running. Because of this particular feature, it is often referred as competing consumer pattern. So we have multiple consumers, but only one will take the message, and obviously the consumer which is faster is going to take more number of messages. Now we know that there is another service in Azure, that is storage service. There also we have the queue support. So what is that service bus queues adds advantage over the storage queues? These are the basic differences. Delivery guarantee, at least once. What does it mean? The message can be retrieved by the receiver, the consumer, and after consuming, it has to explicitly delete the message. Unless the message is explicitly deleted, it is going to remain there in the queue. That's why it is called as at least once. Whereas in service bus, the same model is supported. That means the consumer should retrieve the message and should delete it explicitly. Otherwise, there is one more feature supported in service bus queue, that is, we can receive the message and as soon as we receive, we can immediately delete it. That means at most once only it will be retrieved. We have transaction support in service bus queue. What does it mean? In service bus queue, if you have multiple messages, you can write your logic in such a way that only after processing all of them successfully, we would like them to be removed from the queue. Otherwise, if processing of any message fails, we want already processed message to remain in the queue. That means we want them to be dequeued. So that feature of transaction, of course, we are going to in detail see that later, is supported in service bus queue, but that is not there in storage queue. Receive mode here is peak and lease. That means we take the message from top, and After taking the message from top, we are leasing that message. That means others cannot receive that message at the same time. After successfully completion of processing the message, we should either delete the message from the queue or it will be returned back to the queue. It has to be explicitly returned back to the queue. Whereas here it is peek and lock. That means we receive the message, we process the message. Obviously, at that time, the message is not going to be available for the others. But if at all we do not successfully process the message will get opened for the others in the queue. And there is another model, receive and delete. This is like at most once. We receive the message, and if the message we received is immediately deleted from the queue, whether it is successful or unsuccessful, immaterial, the message after receiving is immediately deleted. Here we are taking the message only on lease, whereas here the message remains in the queue but it remains locked. Here we will have lock granularity at message level. Here we have at queue level. Batch received. Multiple messages can be received in either case. Batch send. While sending, it is not possible to send as batch in storage queue, but you can send as batch in service bus queue. So with these basic differences, you have to decide in many situations whether to go for storage queues or service bus queues for an application. So as usual, we are now going to build an application. As it opens, I would also like to open the portal. And we already have the service bus account created earlier. All resources. DSS demo service bus namespace I have created. And here we can either create a queue programmatically or we can create a queue from the browser interface portal. I'm creating now a queue from here. I'll call it as demo queue. Maximum size 1 GB, 2 GB, 3 GB, 4 GB. Remember, what I have noted is if I selected 2 GB, maximum size is going to become 32 GB. If I select here 1 GB, the maximum size is going to become 16 GB. That means whatever we give here, multiple of 16 is being taken. Yes, there is no specific documentation or reasoning provided, but you'll see that once the queue is created, it gets listed here, and maximum size will be multiple of the factor which is given here. Maybe at this point of time it is a bug and might get resolved when you are doing this. But as of now, yes, you will notice that difference. Message time to leave 14 days or hours or minutes or seconds. Like that, you can specify how many days a message can be there in a queue. Remember, the storage queue can host a message for a maximum of 7 days. But here you have a bigger duration available. You can specify how many days you want the message to leave in the queue without being retrieved. Lock duration 30 seconds the message is going to remain locked, and if you do not unlock within that 30 seconds, immediately automatically it will get unlocked. Move messages to dead letter sub queue. For every queue, we are going to have a dead letter queue. So if a message is not retrieved from the queue in a specified time, whatever is given here in time to leave, then the message is automatically going to be moved into dead letter queue. So we should have a separate piece of code, separate logic for dealing with the dead letter queues because they were not processed in time. Enable duplicate detection. Same message should not be added twice. Enable sessions. You can have sessions and partitioning. I'm not sure what this partitioning is, but let us keep it. So we'll have a queue created and it will get listed here. Now this queue, that is the demo queue, is what I would like to use while programming in my studio. So I'll create a new project. I'll build a sender and consumer. Two applications I need to build. So first I'll make all the setup. Queue sender demo app. I'll start one more instance of Studio where I'm going to write the code for receiver. This is sender. Add the reference to system.configuration as usual. And important thing is manage NuGet package, and here you have to use service bus. Windows Azure service bus. Same thing I'll have to do in the client. I'll create a new project here also. I'll call it as Q receiver demo app. Here also I will add the reference to system.configuration and the NuGet package service bus. Install it. So here now in the config file app.config we will have app settings with some key and the service bus endpoint. Now, what is the name of my service bus I gave? And finally, here we have to provide the root key. Now, how do we get that? Portal. Go to shared access policies, and from here we can get it. Copy either primary or secondary, whatever you want, and paste it here. Obviously, the same endpoint is also needed in the other application, that is receiver. So switch to receiver, and here also same thing. So basic setup is done. Now we need to write code here to read the message from the demo queue. Sorry, in this is sender. This is receiver. So first we will go with sender, where we have to write code for sending a message into the queue, and on the other end we'll have to write code for receiving the message from the queue. Ideally, I'll copy the code. Pretty simple and straightforward code, nothing complex. Just few lines. This is in system.configuration and this is in Microsoft.servicebus.messaging. So we have got connection string from the app settings. The name of my queue is demo queue. Queue client.create from connection string, where we have to give the connection string name and queue name. So we now get the reference to the client. This client is a queue client. Remember that. That is important. It's a queue client. Now this queue client is what we are going to use for sending message. What is important is each message is of type brokered message, and as a parameter we can give any serializable object or we can give a stream, all serializable objects. That is what is important. Not necessary it is a string, but string is also serializable, hence it is easy. So this is a message sent at so and so time, and we are sending the message. For that message, we are going to get the message ID, and that message as it is, we are printing it here. Successfully sent a message with this ID. Execute the program, Control F5, and we should get some ID and terminate. Good. Post one more message. One more message ID will be there. At different times, we are posting the message. Where are these messages? All these messages are accumulated in the queue. If you go to the portal, you go to the queue, here we have seen the first thing 32 here, and it should show me there are three messages. Maximum size is 32 because I selected at the time of creation 2 GB. Dead letter 0, transfer dead letter count 0. So now we need to write code for processing these messages from the queue. That means we have to write the receiver. Now beautiful thing is in receiver also this part is same. The queue client is not going to change. Whether it is sender or receiver, both of them are queue client. Both of them are client to the queue. But here instead of using send, we are going to write code for receiving it. That is the only small difference. At the time of sending, we have sent what brokered message. So here at the time of receiving also we are going to write code for brokered message only. So queue client dot receive, how many it can receive? Only one. And whatever it has received, that we are getting it in the form of string. This get body is automatically going to do the serialization, and that deserialization, the deserialized data is in string format, and that string we are printing it here. And only when you say complete, the message is deleted from the queue. Otherwise till then the message will remain locked. Very important, the message will not be deleted unless we write complete. And should the message be deleted at the time of receiving, or should the message be deleted by explicitly calling delete? Can be controlled by the third parameter here, which we can give as receive mode. There are two values: peak lock, receive, and delete. Now, peak lock is the default value. What does it mean? Get the message from the peak, that means topmost part of the queue, and lock it. And receive and delete means what? As soon as you receive, immediately delete. Now receive and delete is little critical to be used. Why? After receiving the message, if suppose something goes wrong, even before processing the message, your application crashes. The message is permanently deleted from the queue and it is lost. Whereas in peak lock, the advantage is unless you explicitly delete, the message will not be available to others, nor it will be deleted. Of course, after a timeout period, automatically the lock will get released and then it can be processed by others. The timeout period is 60 seconds. So by default, after processing the message, either we should call complete. If not complete, the other method is abandon. If you don't want to wait till timeout period, you can write message.abandon and the message will get abandoned from the queue. So here I write dot peak lock. Anyhow, if you don't provide this also, it is default. So now I run this, and how many messages we are going to get? Obviously only one. That's it. Then I process once again. I pressed Control F5. Second time I am executing, and one more. One more. Let's run once again. The message is not available in the queue. That is why receive is waiting for the time. But in the meantime, if I have a sender sending the message, immediately the receiver will receive and it is sender has sent and the receiver should have received it. Perfect. So receive method is going to block the current thread of execution till the message is not received. Alternatively, you can give here the time span. You can say new time span or time span dot from seconds 0. What does it mean? Wait only for 0 seconds. That means if the message is there, process it. If the message is not there, terminate. Of course, now I'm going to get exception. Why exception? Because when message is not there, what it does is it returns null, and this is null. So here I have to actually write some logic. If message is equal to null, then I should say console.writeLine no messages to process in queue, and maybe as per this application I would terminate. But if it is not equal to null, we print the message. We get the data from the message by using body. It is as simple as this. So yes, if I take the two applications, sender and the receiver, what do we understand clearly is sender is executing send and receiver is executing receive. For both of them, we have common queue client. Queue client is constructed based on the connection string which is provided in the app settings and the queue name. Of course, in case we want, we can additionally provide how do we want the receive mode, peak lock or receive and delete. So now coming back to receiver project, see right now what is happening is every time I want to receive a message, I have to execute receive. Instead, what I would like to do is if a message comes, it should automatically get received. How to do that? For that, we'll have something called as, I'll comment all this. All this is commented. So what I'll do now is I'll say queue client dot on message, wherein I can provide a delegate instance, action delegate instance, and to that we have to pass an object of type brokered message. So we can actually use a lambda expression message and give here the floor bracket and terminate. So basically anonymous method is there now. So as soon as a message is received, automatically this block is going to execute. What we do here again from that message, we can say get body, and we know that in our case it is of type string, and that string return is printed. That's it. Now in on message, you don't have to write explicit code for deleting. On successful completion, on message is automatically going to delete the message from the queue. So now what is the advantage of this? I will have the receiver running. See, it terminated it. Okay. So what we'll do is here we'll just hold the application. We'll not let the console application terminate by using read line. So read line indicates that the program should not terminate. So on message will be able to receive the message, and as soon as it receives the message, that block of code, the anonymous method specified is going to execute. So now I go to sender, execute this. I'll keep this on top, and you see automatically it is received here. So actually you can make a small change now to the sender also. What is that? I'll put a loop here, while true, indefinite loop. Only when I press Control Z or maybe Control C and terminate, the program would terminate. Otherwise, it would not. So every time I'm creating a new message and sending the message to the queue, and I will ensure that this is going to sleep for maybe 5 seconds. So can I say this application is sending messages at a regular interval of 5 seconds? Yes. So let us see. I run this. Now I go back to my running instance of the receiver. And here we will notice that messages are getting received automatically. See, every 5 seconds, the sender is sending the message, printing the message ID on the screen, and the receiver is receiving the message. Infinite. And whenever I want, I can terminate this. So like that, some improvisation is possible. That is what I am trying to tell you here. The sender need not send only one message. The sender can always send multiple messages if required. And here, because of on message, we are able to retrieve. Just to make it simple for you to understand, what I'll do is, I'll give you a action received message, a method as per the delegate, brokered message. And this code which I wrote in this block, I'll put it here. And what is required here? Delegate. So that I'll give new action, and as parameter I can give received message. More cleaner code, basically easy to understand. So we are passing a delegate, no overload, receive message matches action delegate. Action. Okay. What we need to give is action with received message. On message, brokered message. Data type of the message we have to give here. Or if you want to keep it simple, you can just write the same line by removing action. Just the method name is sufficient, and even this will work. Now I can also extend the same program where the message need not be string. In this case, we have used message as a string, but it need not be string always. We can have message which is an object of some class. So let us say here I have a person class. I'll make this person class as serializable. Now because the person class is serializable, we can pass that serializable object to brokered message. And once it is passed to the brokered message, later on the other end, we can say get message of person. In place of string, you write person and you will get back that object. So not only string, but any custom class object also can be passed to send through a brokered message object, provided that object is a serializable one. This is compulsory. Then only it can be used here. If that is not there, then one more alternative you have is for that object you create a JSON serializer, convert that object in from C# to JSON, and then JSON is nothing but ultimately string. Save it as string in the brokered message. When you retrieve, you get the string. From string, you get back JSON object, and from JSON, you get back the C# object. That can be one more roundabout approach in case the class is not serializable. But if it is serializable, then it is pretty simple and straightforward. You just need to provide the object of the class. As it is, we'll get back here. And I also told you every message can have properties. So when you create a brokered message object like this, for that message you can additionally have properties. Let me copy this and I'll put it in the center application. So this is message, and here I am putting some property. Let us say name is P1, age is 20, location is USA, and I don't want this loop anymore just to avoid confusion. So one message, brokered message, and for that message the key value pairs. How to retrieve it? Pretty simple. On the other end also we are getting brokered message only. This is a brokered message. From this brokered message we can say properties. Here we are using properties collection. Here also we can make use of the properties collection. So message dot of, a message dot properties of